Hola a todos, mi nombre es Ignacio Jauregui, soy miembro del Departamento de Informática en Salud del Hospital y este video es dentro de la serie de Ateneos de la temática de experiencia de usuario en salud que tenemos dentro de la residencia. Y esta vez vamos a tener la oportunidad de recordar una charla que tuvo lugar en las jornadas de informática en salud de 2020, del año pasado, donde contamos con el honor de tener a la doctora Catherine Plaisant. Ella es especialista en lo que es diseño de interacción y ha trabajado mucho en el ámbito de salud. Es también autora de uno de los libros más importantes de la disciplina, que es Diseñando la interfaz de usuario. Y en la charla nos mostró distintos trabajos en los que ella ha participado, donde se representan patrones temporales de eventos en salud de pacientes o cohortes de pacientes y cómo mostrar estos patrones de actividad en marcos visuales para más fácilmente poder recopilar esa información y poder tomar decisiones en salud. Así que bueno, vamos a recordar la charla esa y espero que lo disfruten.
Bueno, vamos a seguir con la siguiente presentación. La siguiente presentación estará a cargo de Catherine Plaisant, que es investigadora senior de la Universidad de Maryland y directora asociada de investigación del Laboratorio de Interacción Humano-Computadora. Catherine tiene más de 200 papers publicados sobre el tópico. En 2015 fue reconocida como líder en el campo de interacción humano-computadora y es coautora de la cuarta, quinta y sexta edición de uno de los libros más importantes sobre interacción humano-computadora. Hi, Catherine. It's really a pleasure having you today. You're going to start when you are ready.
Yes, I hope you can hear me. All right?
Yes.
All right, good. I'll share my screen. And here we go. All right. So hello, everybody. I'm really sorry I do not speak Spanish, even though I'm French. It should not be that hard, but I never learned. So I will try my best to speak slower than usual, which is hard, but I hope it will work for everybody. So first, it's a pleasure to be here with you, and I'm speaking from the University of Maryland, from home next to the university, which is right next to Washington, D.C. Oh, I thought now we have a little problem. Oh, here we go. So all the work I will be presenting, oh, you shouldn't be able to, do you see? I hope you don't see this, but here we go. All the work I will be presenting is from the Human-Computer Interaction Lab. And this is an interdisciplinary research community with people from computer science, information studies, a lot of other places. But you may have noticed, actually, I hope you don't see these messages either, but probably not. All right, so, but you will notice there is nobody from medicine, but you know, we are HCI people, so we work with our users, and we have, over the time, we have worked with many doctors and researchers in the medical domains, and that's how we developed the prototype you will see today. So it's interesting, it's not behaving exactly like I was supposed to, but anyway, so the lab is well known also for mostly the work in HCI, and you know, this book is an example of you know, what came out of the work of people here. But today I'll focus most on information visualization, and we also have a long history of work in information visualization. And as a little, very quickly, I hope you don't all know it, but a small exercise to illustrate the value of information visualization is, we often spend more time on this, but like here are 4 data sets, one for each color. And can you tell something about those 4 data sets? So usually we gave people the time to search, and people might say, oh, yeah, look at this column and this column and this column. They are just the same. It's the same numbers, but it takes a while to see that. And then you might see, oh, look at this column. It's all the same value except for this one, who stands out as being different. And there are other things you could find in here, and typically people might say, well, let's run some statistics. And surprise, all 4 of those data sets have exactly the same statistics, mean, variance, etc. It's the same. But when you look at it, they are completely different. There is really something that the statistics do not tell you in here. And you might find some anomalies and decide if they should be removed or not, etc. And it's really, what the main message here is that statistics are great, but if you never look at your data, you are missing something, and your statistic may be very misleading as well. So the main message maybe about the entire talk is look at your data and using some kind of visualization tool that may be available to you. So back to the history of the lab for information visualization, I'll give a few examples. One of the early tool, actually, we did some research, and then we're lucky us, in this case, it became an actual commercial tool, Spotfire. And that's pretty old already, but that's an example of the kind of environment that we think of when we talk about visualization being more a tool with many views and multiple views, and you are interacting with it. There might be some filters. Here are some filters, so you reduce what you see. You could zoom, you could manipulate the data. And mainly, it's not that you are presenting data, the results. You're exploring the data to understand what's in it, to possibly find trends and exceptions and formulate new hypotheses that may be tested later on using another data set or statistical tools. But it's talking about an exploration of the data itself. Another example of the lab is well known for is the development of tree maps. And the application, funny enough, that made the tree map famous and its use exploded is looking at stock data, where in this case we have several hundred stocks, and each box represents the size of the box represents the market capitalization, and the color represents change compared to a date that you select. So, and in green are things that went up. So you made money here, or you could make money. And the red ones went down. So here is a mixed day, and all the stocks are organized according to a hierarchy. So here are the healthcare stocks, the financial stocks, energy, basic material, etc. So if you look at a different day, you might see, oh, that was a bad day. But there are some exceptions. I bet you could see it. I mean, there are alternative color scheme for people with visual impairments, but here's the exception. Or here's another day where it's a mix also, but you could see like technology is doing well, but the financial and healthcare is not doing that great, except there are exceptions. So what this does is at a glance, you could review the value of a lot of different things and get very quickly a pretty good awareness of how things are going today. Another example, I don't know, here is an example where tree map is used for medical data. In that case, from the University of Washington, it's called GBD Compare. And they are looking at, let's say, what is it? It's cause of death for everybody. And I think it's a change from 1990 to 2016. So they group the cause of death according to, I'm not sure exactly, those are like falls, road injury, violence. Well, those are illnesses. The size of the box is the number of people who died, and then the color tells you, things that are dark, so it increased, like the HIV went up enormously over that time period. Well, the light colors are things that are getting better. So again, at a glance, you could see a lot of various cause of deaths and better have a feeling of what's big, what's small, and how much it changed. Another example is the FDA actually is using tree map. They call it sector map, and they are looking at they are monitoring adverse reaction to drugs. So this is one drug, and this is all the different categories of adverse reactions are grouped in a hierarchy. And you could tell the ones that were bright are the things that using a pretty complex method for measuring abnormalities. They look at what are the adverse reactions that we are not expecting. And apparently this is used every day by FDA employees that are monitoring, what's going on with adverse reaction of the drugs. But let's move on to the main topic of today, which is event sequences. So I'll talk about two main scenarios for this use of event sequences for patient record. The first one being you're looking at the data of a single patient, and over time things happen. He goes to the hospital, or he gets surgery, or he might get a drug or test, etc. Events occur over time. And typically the scenario is like a physician is wondering things like, what is the situation? What has been done in the past? What worked? What didn't work? What should we do now? So that's scenario number one. And the other scenario is you are dealing with a collection of patients, or a database really. And it might be an hospital or an institution, or in some cases a whole country is actually looking at the data from all those patients and trying to answer more questions like, are we following guidelines in prescribing opioids? Are we, can you help me find patients with a certain temporal pattern? Can we improve a workflow, etc.? So more large questions, again, exploring the data, trying to make sense of it and seeing, possibly verifying hypotheses or coming up with the next hypothesis. In general, today, I'm mostly talking about categorical data. So we separate the numerical data, like you may have blood pressure in an emergency room, but here we're talking about events, point event typically. And sometimes people transform the numerical continuous data into events, like the time the blood pressure went, became abnormally high or abnormally low, etc. So mainly we'll focus on those events. And sometimes we deal with intervals, like a drug may have been prescribed for a certain time. So you don't need to read, but over time, we made many, many prototypes at the university. And I'll focus on two for today. And here's just to give an idea, we worked with many different people, and we couldn't do it without them. So the first example is Lifeline. It's a fairly old project, but it's a project that came too early. So it was not used early on, and then only later on, only now, even today, I still get a lot of requests about, learning more about Lifeline and how to use it, or etc. So the idea of Lifeline was to summarize an entire patient record. At that time, we worked with Kaiser Permanente, and they gave us some de-identified example data sets. And we came up with a display like this, which is time, so actually it's over here. And then we would report the different facets that we found in the record. The way typically was organized, each one was a piece of text or a table, and we replaced it by elements of the timeline. So we listed the problems, the allergies, the diagnosis, complaints, labs, imaging, medication, etc. And again, at that time, which is 1998, nobody had everything together, but we were trying to imagine what it could look like when you put everything together. So a lot of you are probably in the medical domain, so you probably could read this display. And one of its strengths is typically you don't need to train people. It's very simple. It's a timeline. We have used timelines for centuries, really. So people are very familiar with this metaphor, which is a great advantage. So you could see diagnosis here. What we dealt with, of course, is that diagnoses are only entered as individual events, but we were trying by a thin line to suggest that it's probably ongoing. This poor person has had migraines for a very long time. You could see the labs, you could see the drugs, and one of the the strong thing is that people could make relationship between the different part of the records instead of having to navigate across many different tabs or different area of the records. And this is a little bit old for me too, so I know there were some others. Oh yeah, apparently there is some drugs where, I forgot which one it is, I think it might be this one, where you have to do a test that regularly for if you take that drug, and I believe it's this test, and then it's time to redo it. Clearly it hasn't been done for a long time. So those kind of reasoning are very easy to do on a timeline. And that worked well for outpatient record that was still several years, but there are many other more complex cases. So overall, it has been used in many systems, and I wanted to give some examples of what kind of different ways it's being done. So one of them, and this one actually is in French, it might be hard to read, but you get the idea, is that in that case, the users had chosen which part of the code they wanted to see. And I like how they did it, where they show the actual, those are the diagnosis. It shows you the diagnosis. It shows you also the level up in the hierarchy of diagnosis. But then you could see all the dots correspond to the time where a diagnosis of chemotherapy for a tumor was entered. And you could see here's all the drugs. And again, they are grouped by types of drugs. And you could see all the entries. This was also an example where it's in use also in I2B2. You may be more familiar, like here it's showing multiple patients, but each one has a little line. So the I2B2 was the first one group to use it that I know of. On the other hand, the other end of the spectrum is a case where this was used for a tool for very specific situation was treating prostate cancer. And so they don't let you choose whatever you want to add to this. They had pre-prepared, well, they may do that anyway, but they had prepared a subset, a small subset of things that you always need to have when you are in a particular situation of a urologist seeing someone for prostate cancer. So it shows you the PSA value. I mean, there is still the drugs and all, but it's more reduced and there is much less complexity. It's more readable. They even added, in this case, the numerical data. So just to show you kind of another example of how this has been used. Another example is there was focusing only on the drugs, just the drugs. So again, it's a timeline. You have today, I mean, the hypothetical today, and you could see the drug that the patient is actually taking today. But it's really there is here an overview of going back to many more years back. And it shows you here what we're seeing in the detail here. And you could navigate and see really go way in the past. Here they had chosen to show for color, I mean, not color, but the color was used is the shade of gray was used is telling you if you could increase the dose or not. So the one who are very dark, you reach the normal high dose. You shouldn't really go higher than this. While those are still a low dose. So for example, this drug, they started gabapentin, they started with a low dose, increase the dose, still increasing the dose in here also. So that's one example where just looking at the drugs for a complex case, it just fills up the screen. You don't even need to scroll. I mean, it's crazy. I had no clue how many drugs people could be taking at the same time. A final example might be that's the iPad version of Allscripts, and they do use also the medication. They have a little display here, and from what I gather, you know, it's really appreciated as a quick way to get an idea of what has been done in the past, and instead of just knowing what the drugs are today. So I continue. For Lifeline, again, it's been used in different places, but it's interesting also to think of what has not been used. You know, what are the ideas we had come up with and that's still not implemented today. So one of the examples is it would be so wonderful to be able to filter by diagnosis. Like you pick one of the diagnoses and it would show you all the drugs and the tests that were done in relation with that diagnosis. So that we still don't see it. Another example is like when you have a lot of data, and this is a toy data set, by the way, it's a toy data set. A lot of cases, you don't have enough room to show everything. So you need to zoom in, or like your hospitalization, where is the hospitalization? Here, you were hospitalized for pneumonia. There is tons and tons of data under here, and you need to zoom in and see more detail. So that's how do you reveal more detail as you zooming is not something I've seen well implemented in the tools I've seen. But just for fun, there's a little video of the original toy data set we use, and you'll see people zooming in, and then you could see what's abnormal. You know, the only pap smear was abnormal, and they repeated, and it's okay now. And then I also see that you could close the facet, but you could still get an idea of how much stuff is in there. So if you had a lot of data, you would reveal the rest. And now we'll see the example of the zooming on beta blocker, and it will show you more detail. Now you could see what drug it was really. And then you could imagine zooming more and seeing the doses, etc. So just a little example. So that was, we were looking at an example of design for a single patient. And I know this is growing and more people are using it, and there is a lot more we could do to improve the question of labeling, even usability. Like people think that zooming on a timeline is easy, but it's not easy for everybody. So there is a lot of as an expression goes, that the devil goes in the details, is in the details. So to make it work really well, you have to do a fair amount of usability testing to clean it up. So the other scenario, let's move on to the other scenario now, is dealing with a collection of patients and more general research questions about how phenomena in the data. So I'll focus on one tool called Event Flow, who is available, by the way. And originally, it all started with a collaboration with an hospital, and the specific question which led to Event Flow, because almost everything we do is done by observing people and talking with them about what else would you like to be able to do. And one of the questions was the director of the emergency room telling us, I do not really know where the patient in my emergency room are going after they leave the emergency room. Where are they going? So we worked with them and extracted the transfer from the hospital, and mainly it looked like this. Like every line is a different patient, and you could see how they move to different part of the hospital. So arrival is simple. They go to the emergency room. They might go to the ICU, intensive care unit. They might die or be discharged alive, or they may be sent to a normal hospital room, which is called floor here. So, but we still needed a way to summarize the sequences. So what Event Flow brought is that way of summarizing all the sequences that you find in the records. So I have a little animation that explains how that Event Flow overview is constructed. So imagine you have a bunch of events over time, points or interval, and we're going to line them all up here as little bars. And then now you have several patients, 1, 2, 3, 4, 5 patients, and we're going to align by the first event. So I'm aligning, and I'm going to draw a bar for the first event. In this case, they all started with that red event. So now you have a bar. Everybody started with a red event. Now we're going to look for the second event. What's the second thing? So we have orange or green, and there is 2 orange, 3 greens. We're going to regroup them. So the most common is at the top. There's more green, or more orange than green. And then we're going to draw a bar at the average. So now this is telling you that on average, it took that amount of time between the red event and the green event. And you could tell it took longer between the red and the green than between the red and the orange. Oops, sorry, I went too fast. So now we look at the next event. In this case, after orange, they all went to green. After green, they all went to blue. And again, we're going to draw a bar at the average. There we go. So it continues like this. And at the end, you have a summary that tells you an idea of that corresponds to the number of records. So there is more records with this pattern than this pattern. And this is an indication of time. So you have to remember it's the sum of the average between those events. So, right? So now if we go to our event flow display, the best is I'll show you a little demo. And if all goes well, we'll have a little video, which is started. All right, I'm back. So I hope you were able to follow this example. And I'll go through a few small examples. And again, there are samples because we can't share the real data, so they are small, but they give an idea of what you could do. So this example was looking at different treatments after a particular diagnosis. So I think that was a cancer diagnosis. And so that the diagnosis is here, everything is aligned by the diagnosis, and you could see what's the most common treatment, the purple treatment, or the second most common is the brown treatment, but sometimes you get the purple and the brown, and then another one, and so on. You could see people who did not get any treatment at all, and so on. So again, that gives you an idea of the proportions, what's the most common pattern, the less common pattern, and it gives you an idea of the time between those events. Right? Another example is looking at drug data. And to look at drug data, not always the case, but in some cases you care about the coverage, how long did that person took the drug. And so you have two drugs, and then you could show the patterns again, but you could show some. It's not that easy, but if you don't have too many colors, you could show overlap, whereas in this case, this person took both the red and the blue drug at the same time. But the real data looks more like this, where it very quickly gets a mess. And every time we looked at drug data, it was just, especially the drug data from, from the payment records. So they are very messy. And the one thing that was very helpful to clean up this data is to look at, deal with the issue of small gaps and overlaps. There must be some here, but I don't see them, but gaps and overlaps. So we, for this particular thing, we started adding some ways of manipulating the data or transforming it to simplify it in order to simplify the pattern. So an example is getting rid of the gaps and again, the overlaps. So you could specify, like here, in that case, we remove the gaps of less than 14 days. So this gets continued now. And then you could remove the overlaps of less than 14 days. And if you want, add them at the end. So that makes a big impact on how you could simplify the patterns. And just to give you an example, one of the projects we had with an economist actually was looking at adherence using large-scale claim data and what the impact of how you deal with those overlaps and gaps actually to see if we do some sensibility analysis. Another example is the CDC used event flow to look at how giardiasis, that's hard to say, giardiasis is being treated. So the expected clinical event sequence is you see symptoms, you give a test, you have a diagnosis, depending on the test, and then you prescribe some antiparasitic, and you definitely do not prescribe antibiotics. So they looked at a bunch of records that had the diagnosis of giardiasis, those people who have been diagnosed. And, and they looked at those three events, mostly test and the drug. So first we're gonna look at that. So here's an example of a bunch of patients that all had, so the test actually, the green is a test, and then purple is the drug. So this is kind of what's expecting. You have a test, and then everybody had the diagnosis, and then you see the drug. But there is a lot of, it's almost like every time anybody looks in the real claim data, they see an incredible set of pattern of things that they didn't expect. So you have people who repeat it multiple times. You have people who get the parasitic, but they never got the test. A flurry of abnormalities, really. Another example is pediatrics, so kids who have the diagnosis. And so like in this group, a third had the test first, another, more than a third really, had the antiparasitic directly without doing the test. Here this one, the test came after. In this case, they had antibiotics. I mean, it was really crazy pattern you didn't expect. So what's interesting is they had done all the statistics on this data without looking at it. And then by seeing it after that, they really changed the way they were trying, what they used and what they eliminated. The picture of what they found was very different. So there is a paper in here, you're interesting. What's interesting is that those pictures, I'm not sure they even occur in the paper, but it's an example where if you don't look at your data, you're gonna not necessarily explain it or analyze it properly. Oh, yeah, right, that's what I was saying. Yeah, and of course it tells you the number of days, like this is between 2 tests to 21 days. Alors, do I have time to do this example? I'm gonna skip it because I want some time at the end. No, 38. Yes, I'm going to skip it. So we did a lot of studies like this, and you could see them on our website. But maybe, and you don't have to read this in detail, but what I wanted to say is that we try to look for all the strategies that people use to clean up their data, really. Because what happened is that at the beginning, the patterns are crazy. The patterns are almost, sadly, they are like your fingerprint. They are all very unique, but you need to do some data transformation to make the patterns, the important pattern, come back up and tell the story. So like even for this one, I was listing all the strategies that people use to actually get to the answers that they wanted. Just one plug for some colleagues from France also who have taken the tools that we have. Let's be honest, the tool for event flow does not scale up to a very large size. You have to do a lot of only a small portion of the features that event flow has, but it allows you to scale to a large number. So what we recommend is that people start with event flow, really understand their data, manipulate it, simplify it, and then verify with another tool to see that do scale up with pointed questions. So to summarize this part of the presentation, for event analytics like event flow, allows you to review the data from individual records to find the problems really and to come up with a strategy for how to better summarize and come up to the right answer. Search for patterns in the data, and temporal patterns are extremely difficult to specify with query language like SQL. So a graphical tool like you saw in the demo is very helpful to help non-computer scientists to ask those questions. Then summarizing all the event sequence allow you to discover patterns, understand the prevalence of those patterns. Performing data transformation help you sharpen your view so you don't have a mess. You have something simpler that will answer a question. And then, of course, at the end, it's very often you narrow it down to something that you could export and do further study. I'm going to skip this too. And I just want to mention there are many other tools in event analytics, but I'm going to skip and switch to another demo for the last 5 minutes just to give you something completely different. I will skip this and escape and show you this one and start it. Just a little flavor. Won't go into detail, but it's a cool demo that people like. So this is the completely different problem of medication reconciliation. You may have heard of, it's a typical scenarios. You get to the hospital, where the hospital asks you, what drugs are you taking at home? And then drugs are administered at the hospital. And when you go home, somebody, a doctor typically, has to compare those two lists, decide what you keep or not, what needs to change. And then they provide a reconciled list of things you need to take home and sign up. So it's not that easy because you have two lists. And now you're like, typically you have to look, okay, acetaminophen, oh, that's the same thing, same number, same or way to give it. Oh, here's the difference. So that's different. So I'll have to decide which one. Then this one, so it's almost the same. This one, oh, it's exactly the same. And then you go on like this. This one is the same, almost the same. This one is unique for this side. This one is the same. Those are unique, unique, unique. And so it's very intensive to even compare those things. So we can help. As good user interface designers, we can do better. So we use a good layout, multi-step animation, and carefully designed animation. And I'll show you a little video. Stop share. So we are back. And I'm afraid I won't be able to understand your question in Spanish, but hopefully somebody could translate if needed. But
thank you for your presentation, Catherine. It was amazing. We have time for 2 questions. One of them is, in your opinion, what is the best way to display data when you have different users with different goals? What is the best way for complying with all?
Yeah, that's the story of our life, right? So, of course, the answer I could say is also very generic in the sense like it depends. Let's say if you are dealing with a researcher who is going to be using the tool, or researchers that will be using the tool a lot, then you might say, oh, you need a tool with a lot of options so that you could do different things and change, have ways to customize it. On the other hand, if you are dealing with people who have different needs but are using it occasionally or maybe only once, then I would, I think it's better to have different versions of the tool. And ideally, the developers have some good design that transform easily from one to the next. We have done also some tools, some prototypes that try to gently push the users from simple to a more advanced. Like you would start and there is only 3 buttons, a few things you could do. but then you could go to the advanced features, and then it adds features and ideally explain what they do. So it's a really, I don't think anybody has the answer, but that was my attempt.
Okay, thank you. And the last question is, what were the biggest challenges you faced on this topic?
Oh, yeah, that's right. I mean, there is still plenty of problems. So just to pick the one we started working on, like for the case of event flow with the overviews of all the patterns, we saw people comparing two patterns side by side, trying to find the difference. And that's really hard. So in that case, we made a tool that calculates the differences, but the differences are so complex in themselves that it's also very difficult to evaluate, but at least it's one step. This data is very messy, as you probably know if you have worked with claims data or even medical record. What happened is, one of the issues was the tools we have, they tend to really follow the sequence, completely, whatever is in the data, it will show it to you. But somehow, often the data is not necessarily, the order is more fuzzy. Like maybe 3 things happen at the same time. And you're forcing the data in a way to order it one way or another. And that adds some artifacts that are difficult to deal with. So I know that's still an open question, is how do we deal with the fact that the order is fuzzy while we are forcing it to appear in a fixed order. So I'll stop here, but maybe you have more precise, specific question, I'll try to answer.
Well, we have to continue with the next presentation, so thank you for all, Catherine.
All right.
It was a really pleasure.
Bye-bye.